Dear colleagues, author of this talk, Jordan-Gauss graphs and quadratic public keys of multivariate cryptography, Vasil Ustimenko, me, and Alexander Pustovit are very grateful to organizers for the invitation and opportunity to take the floor at ITA. So this is our affiliations. So Jordan-Gauss graphs are bipartite graphs given by special quadratic equations over the commutative ring K finite with unity with partition set K power n and K power m such that the neighbor of each vertex is defined by the system of linear equations given in its row echelon form. We already use family of these graphs for the construction of new quadratic public keys of multivariate cryptography. Some of these keys were presented at my talk at ETAP 2023. This talk is dedicated to the obfuscation of previous construction of quadratic public key via the change of Jordan-Gauss graphs for their special temporal analogs. Examples. Double Schubert graph DSNK is a bipartite graph with the points of kind x1, x2, xn, x11, x1 to xnn from K, and line y1, y2, yn, ynn, yn2, yn, such that point x is incident to y if and only if the conditions xij minus yig equals xi times yg holds for each pair ij. Generation of quadratic multivariate encryption rule f of kind xn1 goes to quadratic expression f1, x2 to f2, xm to fm, where m is n squared plus n number of coordinates, requires the computation of the walk of selected length L in this graph. The information T on the algorithm of generation and the walk in the graph are known to key owner Alice as her private key. This information allows her to compute the image of the map F. Public user Bob has only polynomials Fi written in their standard form. Now, we obfuscate graphs DS and K and consider their temporal analogs. So here, xij, yig, and xiyg in equations 1 appears with coefficients a, b, and c, ig, which depends on time t. So we can change them during a selected moment. Values of IEG, BIG, and CIG are supposed to be non-zero. And AIG and BIG supposed to be not a zero divisors. So in selected moment of time, it's easy to check that we have statics with constants, Jordan-Gauss graphs. The change of DSN key for its temporal analog allow to construct new pair f prime t prime instead of previously computed ft. The piece of information t prime is essentially larger than size of t. We prove that f prime remains to be a quadratic map. This technique allows us for each quadratic automorphism f, kx1, x2, xn, with the secret tripdot accelerator t as above, construct the quadratic selective map f prime of kt t equal n squared plus n onto kt minus s for some parameter with the tripdot accelerator t prime, which is larger than t. So we introduce enveloping tripdot accelerator for instance, Matsumoto Imai crypto system over finite field of characteristic 2, oil and vinegar public keys over finite field FQ, or quadratic multivariate public keys defined by Jordan-Gauss DNK. Recently, we generalized this technique on case of surjective maps. So now the bijectivity is not important, and we can select, for instance, non-bijective cryptosystem TOUV, triangular unbalanced oil and vinegar cryptosystem, recently presented by Jintai Ding and his team of researchers to National Institute of Standardization Technology of USA. That's the link. So we can start with TOUV and get more general obfuscated crypto system. Thank you very much for your attention.